All right, so hopefully you've already done the drill, but if you haven't, one of the things you want to do here is it suggests that we make a table of values, and that's what we did in class last time. So you want to choose your x values and choose your y values, or you can choose x and choose y. I'm going to choose y to be 0. So if y is 0, that means that 7x equals 5. And so that means that x is 5/7, which is a little less than 1. Then I'm going to choose x to be 0, because 0 is just a really easy number to plug in. So 7 times 0 is 0, so y equals 5. So I put a 5 in there. And then if I want one more number, maybe I'll let x be 1. So if that's 1, then that means that 7 plus y equals 5. So that means y is -2. And especially easy when one of these is a fraction. So we know that we're going to have 0, 5, and we're going to have 1, -2. So I've got those two key points, and so my line should look a little something like this. So I didn't really have to worry about plotting that 5/7. Likewise over here, I could choose different values for x and y. So if I let x and y, if I let x be 0, well, 3 times 0 is 0, so 5y equals -5, so that means y is -1. So then maybe I let y be 1. No, I'll just let x be 1. So then we have 3 times 1, which is 3, plus 5y equals -5. So that means 5y equals a -8. So that means y equals -1.6. And then maybe I want to put in 2 for x. So this is kind of hard to see, but that is a -1.6. So I put in 2. 2 times 3 is 6. 6 plus 5y is -5. So 5y is -11. So 11 divided by 5 is 2.2, but since it's negative, we're going to have -2.2. So I have 0, -1. I have 1 and 1.6, and I have 2 and -2.2. So let's look at a little something like this. And again, these are estimates, folks. It's not a big deal. They're estimates. Okay? So when you look at this, that's what our graph should look like. Nice job. Give you a second to jot these down. We will have a quiz next class. The quiz next class will be on what we did last class, which is graphing by making a table, plotting points. This is me getting a drink. And the students will be able to use intercepts, slopes of lines, properties of lines in order to graph lines in the Cartesian plane. So we're going to be able to use intercepts, slope, and properties of lines to graph lines in the Cartesian plane. This will also be on your quiz. An intercept is a point on the graph which crosses an axis. If it crosses the x-axis, it's called an x-intercept. If it crosses the y-axis, it's called the y-intercept. Interesting. The y-coordinate of an x-intercept is 0, so the ordered pair is x, 0. The y-intercept is when x is 0, so it's 0, y. So you want to remember that when you're doing this. So like we did today on the drill, on that first drill problem, these right here, I actually used intercepts. I graphed my x-intercept and I graphed my y-intercept. Because this was a decimal, I decided to graph an extra one. But we're just getting an idea of what the graph looks like. So when you find these x-intercepts and y-intercepts, you want to do it by plugging in 0 for x and for y. So we're going to graph this by finding intercepts. So to find the intercepts, we're going to have 2. So the first question is, to find the intercepts, we do the x-intercept. The x-intercept occurs when y equals 0. So we put 0 in for y. So 2 times 0 is 0. 3x equals 12. How do we solve that? Yep, divide by 3, and so x is 4. So our ordered pair is 4, 0. Then we find the y-intercept. The y-intercept occurs when x equals 0. So we have 3 times 0 minus 2y equals 12. So negative 2y equals 12, which means y is negative 6. So our ordered pair is 0, negative 6. And we plot that. And we connect the dots. Now if we wanted to check to see if we were right, we could pick another beautiful point on that line. And for me, when I see a beautiful point, I see this beautiful point right here. And that's the ordered pair 2, negative 3. So if I wanted to, I could plug that in. 3 times 2 minus 2 times negative 3. Should that equal 12? Well, if it's on the line, it should. So we have 6 plus 6, which is 12. And that works. So I know that I have my line graph correctly. So the key there is to pick a nice lattice point so that you know what the ordered pairs are. Okay, here our equation is in slope-intercept form. We can still graph it by finding intercepts. Our y-intercept is when x is 0. Our x-intercept is when y is 0. So we let y equal 0. So we have to do a little equation solving here. So 0 equals negative 2 plus 4. So we're going to subtract 4 from both sides. Or I add 2x. And then we're going to divide by 2. So x is 2. So we have an ordered pair at 2, 0. And then we have y equals negative 2x plus 4. We want to find the y-intercept. So we let x equal 0. So 2 times 0 plus 4 is 4. And we plot that point. So there's 2, 0, there's 0, 4. And if I connect, if I want to check this, again, I have a nice lattice point right here. And that's the ordered pair 1, 2. So if I check that, 2 equals negative 2 times 1 plus 4, which is 2, and that works. So it's just another way to verify that you've got it going good. Okay, take a second and try this one. Pause the video if you want and see what you come up with. So to find the x-intercept, we let y equal 0. So 4x equals negative 12. So x is negative 3. So we have the point negative 3, 0. The y-intercept is when x equals 0. So 3y equals negative 12, so y is negative 4, and we have that point. And we connect those dots. We plot negative 3, 0, and we plot 0, negative 4. And when we connect these, I don't have any really nice lattice points here. When I look at my graph, there's no nice, super nice lattice points to check. So I could check any number I wanted and see if I get close to that. If I wanted to look out here, it looks like I might have a point here at 3, negative 4, but I might not. So I could put in 2 for x. So if I put in 2 for x, that's 8. When I subtract 8, that's negative 20. 20 divided by 3 is like 6 point something, and I'm about 6 point something. My line's a little off, but that's okay. Another one, same way. So when y equals 0, x is negative 5. So we have negative 5, 0 for our x-intercept. Notice I'm writing that as an ordered pair. Our y-intercept occurs when x equals 0. So we have 0, 3. Well, we can see that my line is a little off there. Now, but even so, you can see that we plot those 2 points, and even so, really, we can see that this 1, 2, 3, it looks like I plotted it at 4 instead of at 5. But it's just going to make my line a little off. So it makes it harder to check for lattice points. Sorry about those, guys. A horizontal line is a line of the form y equals c, where c is a real number. Y equals c. Y equals c. Y equals c. Why is it y equals c? Well, remember our x and y axes? Our x-axis is the horizontal one, and our y-axis is the vertical one. But if I want to draw a horizontal line, I've got to draw a horizontal line in such a way that it's going to intersect the y-axis. So it's going to be y equals some number. A vertical line is of the form x equals. Why is it x equals? Well, it's x equals because it's going to be parallel to the y-axis, and it's going to cross that x-axis. So it's going to look like that, and it's got to go through the x-axis. So that's why it's always x equals a number. X equals a number. Now let's talk for a second. What's the slope of this horizontal line? What's the slope of the vertical line? What slope? Remember, we calculate slope. I know in period 2 the other day, Parrish told us that it was rise over run. So when we look at a horizontal line, do we rise at all? No. So there's 0 rise. And do we run at all? Yeah, we always run. So that's 0 over 1. So our slope for a horizontal line is 0. Well, if we follow Parrish's example and we look at a vertical line, do we rise at all? Yeah, we rise always. But do we run at all? We don't run at all. So we have 1 divided by 0, which is really undefined because you can't divide by 0. A couple quick graphs. You will have to do this on your quiz, just an FYI. It says graph x equals 4. These are the easiest ones to graph, and people miss them. When it's x equals 4, that means it's a vertical line because it says x equals. When it says x equals 4, that's what you got to do. It says x equals 4. So we go to where x is 4, we put a dot, and we draw a vertical line. If it says y equals -2, well, I know y equals, looking back in my notes because I have a great teacher, y equals -2 means I'm going to have a dot at the y-axis at -2, and I'm going to draw my line through that. Horizontal line, slope of 0. Then it says graph 3x equals -15. Well, if I'm graphing that, when I look at it, it looks like it could be either vertical, horizontal, or oblique. So I'm going to solve this for x. So when I solve for x, I find out that x equals -5. That's my line. Since it's x equals -5, is it horizontal or vertical? Nice! It's vertical. So we're going to go to where x is -5 and draw our line. Here we have an equation, y plus 3 equals 4. Solve it. Subtract 3 from both sides, and y is 1. Since it says y equals 1, that's a horizontal line. Horizontal lines means it goes across when y equals the constant. Our constant is 1. So we're going to go right through there. Slope. Slope of a line. Let me get a drink. Slope of a line is used to represent the slope or the tilt of a line. The letter M is used to represent slope. Does anybody know why M is used to represent slope? Okay, that's a question for just in case you're ever on Jeopardy. M is used to represent the slope of the line because it's from the Latin word to climb, which starts with the letter M. When we look at the slope, we think slopes of mountains or hillsides or the slope of a roof, and those are all things that you climb. Slope can be defined in several ways. Of course, it can be defined in change in y divided by change in x. That's what these symbols here mean. These triangles, these are deltas, and those deltas means change in y over change in x. Rise over run, as our dear friend from period 2 said, which means the vertical change divided by the horizontal change. Or if you're given 2 ordered pairs, and this is probably the one that you're most used to. Okay, so what I'd like for you to do is think about, when would I use rise over run to calculate versus when would I use y2 minus y1 divided by x2 minus x1? Well, if I don't have ordered pairs, I can't very well use this, right? So I'd use this one anytime they give me two ordered pairs, but if I'm looking for this, just rise over run, I might be using that when I have a graph, and they ask me, look at the graph and decide. So if I'm given a graph here, that could be y. I would use rise over run. And down here, I'm going to use, this would be used when I'm given 2 points. Or maybe I'm given 1 point and I need to find the equation. So if I'm given 2 points, then that's what I'm going to do. So the first thing we're going to do is calculate the slope of a line. We're going to use the ordered pair policy. So we're going to use the points 3, negative 10, and 5, 6. And you're like, Finn, why are we starting with a negative? Well, why not? The negatives are where we all struggle, so let's start where things are hard. So we've got negative 10 minus 6 divided by 3 minus 5. Negative 16 divided by negative 2, our slope is 8. Now if we graphed this, we could have calculated. We went up 8, right 1. Up 8, right 1 to get on our graph again. What if we wanted to connect the points negative 420? Negative 420, and negative 8, 8. Finn, you got two negatives. It's okay. We can still do this. The important thing to remember is up here in our formula, and this is something I think people get confused about. When we do y2 and x2, see the ordered pair here was negative 10, 3, so we have negative 10, 3. Then we did y1 and y2, right? So when we do y1 and x1, that's this ordered pair. It doesn't really matter which one comes first as long as they're paired with their partners. Okay? Just like you guys, if you're with somebody, you want to be with them all the time. So here's our two partners lined up. Okay? So you want to make sure that when you're doing that, you've got your partners together on top of the right person, if you will. So 8 minus 20 is negative 12. Negative 8 minus negative 4. Minus the negative is plus positive. So when we do our plus positive, that gives us negative 4. So we have negative 12 divided by negative 4, which is 3. So that's our slope of 3. Which means that we would rise 3, run 1, because that's like 3 over 1. Just like here was 8 over 1, we would rise 8 and run 1. Now, if we're asked to find the slope from the graph, one of the things you have to be careful of is your scale. And I did this intentionally when I chose these particular graphs. So what I'm looking at here is when I do rise over run, notice this said it went up 10. It went up 10, but Finny, it only went up 2 blocks. Yeah, but if you look over here, this is 5 blocks, that's 5, and that's 5. So that's 5 plus 5, which is 10. And then it ran to the right. It went 5 blocks. Finny, why is that 5? I thought the blocks were counting by 5. Well, just like you guys, sometimes the scales are screwy, and you got to count by ones on the horizontal. So the ones were horizontal, so we went up 5 and right up 10 and right 5. So our vertical change was 10, our horizontal change was 5, so that gives us a 2. So that's our slope. Notice the next question has us going down. Okay, so we're going down 20. Why are we going down 20, Finny? Well, again, these are counting by 5s. 10, 15, 20. And then we run to the right 5. Well, if we run to the right 5, 20, since it's down, it's negative. So we've got negative 5 divided, negative 20 divided by 5, which is negative 4. One other thing I just want to point out here. Let's say you see the world differently. That's fine. You could have started out by saying, hey, I'm going to go right 5. And I'm going to go up 10. So that's still going to give me the same thing, right? Up 10 divided by positive 5 is still 2. Here, say I wanted to say I'm going to go from here and I'm going to go right 5 and I'm going to go down 20. Or you went from here and you said I'm going to go up 20 and I'm going to go left 5. Well, if you go up 20, that's a positive 20. And if you go left 5, that's a negative 5, which gives you a slope of negative 4. So either way, they're still the same. Now, the slope of any horizontal line is 0. The slope of any vertical line is undefined. Graph each of the following lines, then find the slope. Well, look at it out here. We kind of talked about this earlier. We're going to divide both sides by negative 1. So x is 3. That's a vertical line. We put a dot at 3, and we draw our line through it. Now, what's our slope? Well, if we're going rise over run, we rise 1 over 0. That's 1 over 0, which is undefined. If we look at the second equation, we've got 3y minus 2 equals 4. So we add 2 to both sides. We divide by 3. So we get y equals 2. Boom. And again, we rise none, and we over 1. Rise none over 1. Rise none over 1. So that's 0 over 1, which is 0. Any horizontal line has a slope of 0. Any vertical line has a slope that is undefined. Now, slope-intercept form of a line. Y equals mx plus b. M is our slope, and b is our y-intercept. I've often wondered why they used b, and I think it's because, and I always relate it back to it's the beginning amount. It's where you started. When x is 0, this is what our beginning is. So b for beginning. So what we're going to do is we're going to take the advantage of this is when we write a line in this form, it can be graphed and the y-intercept can be identified easily. So the first thing we want to do is find the slope and y-intercept. Well, what's the slope of this line? Remember, the equation is written in y equals mx plus b. Where's the slope? Well, the slope is in front of x. No matter where x is in the problem, if it's y equals mx plus b or y equals b plus mx, x, the number in front of it, is our slope. The number in front of our x here is 3, so our slope is 3. What's our y-intercept? Well, you'll notice over here that it says y equals mx plus b, but over here it's minus 2. So what's our y-intercept? Well, our y-intercept is negative 2, because if you needed to make it match perfectly, you could make it a plus negative 2. Now, if you had to graph this, it's very simple. You would take your x and y axis. There's my x, there's my y. We'd start at negative 2. We'd go up 3, 1, 2, 3, and right 1. We'd go up 3 and right 1. Bam. The other beautiful thing about this form is it's ready to be typed in your calculator. So you could go to y equals on your calculator and you could plot points from the table if you wanted to. Now, is this equation in slope-intercept? No, because it doesn't say y equals. So in order to get it in slope-intercept, we have to divide everything by 4. 5 divided by 4, 5/4. Now, some of you might want to change that to a fraction, which is fine, or change the fraction to a decimal, which is fine, but I caution you to remember that slope is rise over run. So what's our slope? Well, it's 5/4. What's our y-intercept? 2. So when I look at this, if I'm going to do a graph, I'm going to start at 2, then I'm going to go up 5, 1, 2, 3, 4, 5, and write 4. 1, 2, 3, 4. So that gives me a better way of assessing my slope, as opposed to if I made it a decimal, it would be 1 1/4, which would mean I'd go up 1 1/4 and go over 1, which is more of an estimate. I'm still on there. Here I'd be going up 1 1/4 and over 1. But it's harder to estimate when you're between. So 5/4 is easier to graph. Now, what's the slope and y-intercept here? Well, this is in standard form. This is not in slope-intercept form, so we're going to solve it for y. So we subtract 4x, and then we divide everything by 2. Because in order to be in slope-intercept form, it has to be y equals. So y equals negative 2x plus 7/2. Well, what's my y-intercept? What's my slope? Well, my slope is always the number in front of x. When it's solved for y equals, is the number in front of x. So in this case, it's negative 2. My y-intercept is 7/2. Now, this is one I probably would maybe want to make into a decimal, because when I graph it, all I need to do is plot that point, 3/2. So I do 1, 2, 3, 4, and I'm at 3.5. And then I'm going to go down 1, down 2, right 1. And I would go down 1, down 2, right 1. And so the graph would look a little like that. Okay? The other thing that's cool is when x equals 0, I get 3/2. When y equals 0, I get 7/4, which is just a little bit before 2. Try this one. Okay, parallel lines and perpendicular lines. Parallel lines, two lines that are parallel to one another have the same slope. They will never intersect. They will have the same slopes. They will have different y-intercepts. What happens if they have the same slope and the same y-intercept? Well, yeah, they're the same line. Parallel lines are denoted by the symbol LL, or line. It's a para-else. Parallel is a para-else. Perpendicular slopes have the following properties. They intersect at a 90-degree angle. They have opposite and reciprocal slopes. That means if I multiply the slope of one times the slope of the other, their product is -1. So if I said, hey, one line has a slope of 1/2, then the perpendicular line would have a slope that is opposite, so instead of being positive it would be negative, and the reciprocal. So what's the reciprocal of 1/2? 2. If I had said that the original slope was 2/3, well then my perpendicular slope would be opposite and reciprocal. Okay, so what's the parallel slope for -2/7? Good. Perpendicular, 7/2. Parallel slope for 5. 5. Perpendicular would be opposite, so that makes it negative, and reciprocal, which makes it 1/5. Parallel slope of 0 would be 0. Perpendicular slope would make it opposite, so that'd be negative, and reciprocal, which would be -1/0. Can you divide by 0? So it's undefined. So that's why horizontal lines and vertical lines are reciprocals. Okay, so what I'd like for you to do is try these 4, and then I'll post the answers. Thanks.